I've remarked that IComparableT is the main interface for natural comparisons. The idea is that if some type T wants to declare that T instances know how to order themselves, then it'll do so by implementing IComparableT. IComparableT provides just one method, called CompareTo, which takes an argument of type T and is the thing that the this instance will be compared with. I'll show you the interface using strings, because strings implement IComparableTo, thereby declaring that strings know how to order themselves. I've declared two strings, apple and pear, and I have three CompareTo statements. First, apple compares itself with pear, then pear compares itself with apple, and finally apple compares itself with itself. And each CompareTo is embedded in a console.writeline so we can see what the result is. Let's run that. The first thing you'll notice from these results is that CompareTo actually returns an integer. We have -1, 1 and 0. What do these mean? Well, the thing is, a comparison has three possible outcomes. The two instances might be equal, the first one might be less than the second one, or the second one might be less than the first one. Personally, I would probably have encapsulated these three outcomes by defining an enum, but Microsoft chose to use integers instead, and with a convention. If you think of the value of the this instance, the thing you are calling the method against, as the first item, and the argument as the second item, then the integer returned should be 0 if the two items are equal, negative if the first item, the this instance, is the smaller one, or positive if the first item is the greater one. With that convention, we can understand these results. Calling apple.compareTo pear returned -1, a negative number, showing that apple comes before pear in alphabetical order. By the way, you should read the less than on the callout as pseudocode, which means comes before, not as C# code. Calling pear.compareTo apple returned 1, a positive number, showing that pear comes after apple. And calling apple.compareTo apple returned 0, because apple and apple are equal, so neither one is greater. Don't read anything into the actual values returned, by the way, the plus and -1. The convention is merely that the numbers are positive or negative. It looks in the code so far like CompareTo here is just a normal method, but I assure you it is the interface method. I can show you that by factoring out the comparison into its own method, like this. This is a method called displayOrder. It takes two parameters of any type T, subject only to the constraint that T implements IComparableT, and it displays a message saying which one is greater, based on checking the result of calling CompareTo. And I can use this method by passing in the same combinations of apple and pear, like this. And if we run that, it's given us the results we would expect. That code looks trivial, but it is important. The key point is that displayOrder doesn't take strings as arguments. It depends only on its arguments implementing the IComparableT interface. By the way, in case you're wondering, strings do not implement the comparison operators. If I try to say something like this, if apple less than pear, then you see there's a compilation error straight away, because operators like less than and greater than have not been defined for strings. That's partly why I emphasized you should treat some of the earlier callouts as pseudocode, not C# code. I should also mention that strings are a bit of a special case. Besides implementing IComparableT, string also implements various methods of its own to do comparisons. These methods often offer a bit more flexibility for how you do the comparison compared to IComparableT. We'll look at strings in more detail in the next module.